Okay, what I'd like to do with this session is I'd like to walk you through the formula for correlation, just so you know it. I'm not going to ask you to do it. I'd ask you or encourage you, frankly, is to use the Excel correlation formula for as opposed to using the manual one, but you should know what the formula looks like. So that's what I'm going to do is I'm going to show you the formula and show you what it would look like using that formula. This is, if you've seen my video now on types of correlations, this right here, and let me see if I can actually get this a little larger. Let me zoom in a little bit here. This is the formula. And let me talk through what this formula is. Pearson's R is N, the number of cases that you have, times the sum of X, again, this is between two variables, X and Y, sum of X times Y minus the sum of the X's minus the sum of the Y's, divided by the square root of N times the sum of the X squared minus the sum of the X's squared. Now this is different here. This is where you square the X first and then you sum them. This one here is you sum them and then you square it, times N times the sum of the Y's squared minus the sum of the Y's quantity squared. That's what the formula is. I'm not even going to even hint at trying to show you how that formula is developed. I always want to say, trust me, I actually walked through this one time when I was in graduate school and came out of the other side going, oh, just shoot me. I think that's why I changed my major to psychology. We did that because I kind of went, this just makes no sense to me at all. How could possibly be true, but it is. That's the amazing thing. Let me walk through just briefly again, and I'll take a step back and show you the example of this. R is equal to N, the number of cases, times the sum of the X times Y's minus the sum of the X's times the sum of the Y's, divided by the square root of N times the sum of the X's squared minus the sum of the X's quantity squared, times N times the sum of the Y squareds minus the sum of the Y's quantity squared. Phew. And you wonder why I went to psychology. Well, let me show you an example here. And I'll sort of walk through this in the example here. Here's a set of data, X's and Y's. There are 17 of them. Now, then what I did is I put down the X's here, and now down here I have the sum of the X's, because I'm going to need that number at some point here. Then I have my Y's down here. I have the sum of the Y's. I'm going to click on that. It's like the sum of, up here in the formula line, tells me this is the sum of this set of numbers here. I have the XY's. That's this number times this number. 1 times 12 gives me 12. 1 times 15 gives me 15. 2 times 13 gives me 26. These are XY. The values are X times Y. And down here I have the sum of the XY's, because I'm going to need that one. Then this column here is the sum of the X's. 1 squared is 1, 2 squared is 4, 5 squared is 25, and so on. Then I have over here I have the Y squareds for each one of those things. 12 squared is 144, 5 squared is, I'm sorry, let's do something down here. 21 squared is 441. And down here at the bottom, I have those X's, the sum of the X's, the sum of the Y's, the sum of the XY's, the sum of the X squareds, and the sum of the Y squareds. Now, these things all get put back into here. N times the sum of the XY's. I'm gonna click on this, and what I have here is I12 times D20. I12N times D20. D20 is down here, 1620. That's N17 times 1620. That's what that number comes to. This one over here is B20 times C20. Sum of the x's times the sum of the y's. 91 is B20, that's this one here, 91 times 282. That comes up this number. This number down here, this N times the sum of the x's squared minus sum of the x squared. Now, N is I2, E20, the sum of the x squared, that's this number here, minus the sum of the x's, quantity squared. I took there's B20, which is this thing here, and I multiply times itself. So I took N, I2, which is 17, times the sum of the x's squared, which is E20, minus B20 times itself. I did the same thing here. Work that process through gives me the top part, subtracting this from this gives me 1876. Down here I have 2616 times 1906 gives me 4,986,096. Take the square root of that, gives me 1878 over 2,332.96, gives me a 0.841. Over here, what I did, as I said, use the formula Correll for B3 through B19 and C3 to 319. So I put the range for the x's, the range for the y's, and said, find the correlation of it. It says 0.841. You can do this either way. It's up to you. However, I'm telling you, having done that, I mean, this is how I would go about doing it, essentially, if I were doing it more manually at this point. I just want to note here, if you try doing this stuff manually, at least for me, it's like doing this mathematically and making all this stuff happen and finding the square root of 4,986,096 would take me a little bit of time manually. I could do it, but the likelihood that I would make an error in that is quite high. So, and that's just with 17 cases. If you work for Amazon or someplace like, well, Amazon's a great one. Amazon, if you happen to have an Amazon Kindle and you buy a book through an Amazon Kindle, and Amazon says, given that Steve bought the third book of The Lord of the Rings, what's the correlation between people who buy that and each of these 17 other books out here? And they figure that stuff up based on 2.5 million people who bought the original book, Lord of the Rings, that they have records on. Well, n's equal to 2.5 million in that case. None of us want to do that kind of stuff by hand. Nobody does. That's the value of the Correll formulas within Excel, is because if I had made my n there had been 17,000 as opposed to 17, that process might have taken me all of 5 minutes longer to do. Once you figure out how to do it, it's not hard to do, but you can do it fairly quickly. And then if I just use the Correll formula rather than doing it manually, it doesn't even take me an extra 5 minutes. It takes me, as long as it takes me to put the numbers, the ranges, correct ranges into the stuff. So when you have large numbers of cases, using Correll stuff just makes using the Excel formulas for correlation just makes all the sense in the world, because this formula is a fairly complex formula. I just note for you that you saw my other video on the types of correlations. Those formulas for the other correlation, like row and the point by serial and the rank by serial and so forth, those are also complex formulas. Not quite as complex as this, because if you're using a dichotomous data, you've only got two things in it, so the multiplying back and forth, and that's not real tough. But still, it takes time. And what Excel does is it does it for you really carefully and quickly and accurately. And I am not good at those things myself, never have been, which is why I like Excel so much. But that's the form, and I'll post that file on this week, so you can look at that if you want to. But that's sort of how the formula actually works if you're trying to work through the formula and want to understand the formula behind this stuff, as opposed to just using, say, Corel B2 to B19, C2 to C19, bang, and getting the answer. That's it.